Hello, welcome to the Professor's Du Bois channel. I'm Professor Corey.
And I'm Professor Victoria. This is a continuation of our lecture series for General Chemistry 1. And today we're going to be talking about the units that scientists use to communicate about the measurements that we make, as well as scientific notation and converting between those units.
Let's get started.
All right?
Metric units. We're going to use the metric system. Scientists use the metric system. Actually, most of the world uses the metric system. And we have to be able to communicate with scientists all over the world. So we have to settle on one system for our units, and that's going to be the metric system. And you're probably fairly familiar with most of these, although we're a little more comfortable using pounds for mass. The metric system uses grams, volume is in liters, distance in meters, and time is in seconds. These are called base units.
Derived units are combinations of these. So anytime you have more than one unit, it's a derived unit. So density is an example, grams per milliliter or mass per volume, any mass, kilograms per liter, any type of combination of mass and volume is going to be a derived unit of density. Rate and efficiency are also examples of derived units.
And one thing I might add is, let's look at this efficiency in miles per gallon, and this is something that's not metric system, but let's just look at this. When we write this, let's say our car gets 22 miles, that's per 1 gallon. We could write that as a fraction. I'm just going to bring that up now. You'll see more of this later.
So here's an example of using a derived unit in a calculation. So we have density here. We want to know what the density is in grams per milliliter. So that's what we need to end up with. So that means that it's grams divided by milliliters. These are the units that we're looking for. We want to discourage using this slash and put your kind of vertically over top of each other. So how would we calculate this? If we need grams per milliliter, we can simply take our grams and divide it by our milliliters. So if anything in the numerator is multiplied and anything in the denominator is divided by. So 2.45 divided by 145. 2.45 divided by 145 is 0.0169. And then you have to write both units. So grams divided by milliliters. And that's the same as 0.0169 grams in 1 milliliter. So the 1 isn't often written, but it's implied.
Now, scientific notation we're going to use for very large or very small numbers. And there's a general format to this. And we have this uppercase N, which is a number between 1 and 9, and there might be a decimal. It could be 1.07 times 10 to some power. So,
want me to write it?
Yeah.
Okay. So 1.7 times 10 to the third, say, would be 1.7 times 10 3 times.
That's 3 orders of magnitude.
3 orders of magnitude. It's also the same thing as 1700.
Now, we're going to use scientific notation a lot because we're going to be using really large and really small numbers, and you're going to be doing a lot of calculations, so you have to get comfortable with doing this on your calculator. And we found our experiences, most students aren't using the proper scientific notation function on their calculator. And what you want to look for is a button that has an E or an EE or an EXP. Some of them say times 10 to the end. It depends on what brand of calculator you use. So we have an example here for you to try. On your calculator, do 3.45. Now, if yours has the E, do 3.45 E7. That's the same as times 10 to the 7. And then multiply that by 1.21 E negative 3. We have the answer there for you. Now, your answer might come out in regular notation. 41,745. You can switch between regular notation and scientific notation, and that's usually mode followed by the psi to get to scientific notation. Now, this can be really annoying if you're stuck in scientific notation, so you'll want to be able to go back, and that's typically mode flow.
A common mistake that students often make that I've seen before is that they will put in the number 3.45 and then literally say multiplied by 10 caret 7, and that will usually be off by 1 order of magnitude. So we want to make sure you don't do that.
So for temperature, we're going to use Celsius or Kelvin. These are common metric system units for temperature in science, but we're very comfortable with Fahrenheit, and you may have to convert between Fahrenheit and Celsius or Celsius and Kelvin, and we have the equations here so you can convert between these units.
We'd like to introduce this concept called dimensional analysis, and we really want to discourage cross-multiplication, and we want you to use dimensional analysis. And what this is a tool and a way to convert between units using units cancellation. And what we use is our factors. So we call them conversion factors, and it's a ratio of 2 units that have the same value. So for example, 1 hour is the same as 60 minutes. 1 minute is the same as 60 seconds. These are factors, conversion factors. And we also want to encourage you to always write your units when you're doing these conversions. So let's show you an example. So in this example, we want to know how many dozen do we have in a box of 1,575 donuts. So we have this 1,575 donuts, and we don't want just donuts, we want dozen. And what kind of factor do we have? Well, how many dozen, what's a dozen? And that's 12. So it's 12 of anything. In this case, it's donuts. So 1 dozen equals 12 donuts. That's our conversion factor. So we start with what we know. That's not a factor, it's just our 1575 donuts. We always write our units. And if it's just a number, we know that that's in the numerator. We can put it over 1, and that just kind of shows and differentiates between our numerator and our denominator. If we're going to cancel units, we take the unit that we start with and put it in the denominator. Then we look to our factors. Do we have a factor that can go between number of donuts and dozen? And the 12 has to go with donuts, and that means that our 1 dozen is on top. You can use your conversion factors in any way. Doesn't matter which one's in the numerator or the denominator. That's driven by what you want to cancel. So in this case, we have 1,575 divided by, so anything in the denominator is divided by, so it's divided by 12. So we have 131.3 dozen. So our donuts canceled. We're just left with dozen, and that's how you convert. So that's a very simple dimensional analysis example.
And that's a lot of donuts.
That's a lot of donuts.
So let's talk about metric conversion prefixes. Prefixes are combined with metric units in order to reflect the relative size of the measured quantity. And this is just a chart that you can use to help you realize the factors using these prefixes. So what I'm going to do is I'm going to start with something you might be familiar with. Computers, you've heard of like computer memory, and we could say that a computer memory is in a byte. So 1 gigabyte, you've probably heard of that. 1 gigabyte is equal to 1 times 10 to the 9th bytes.
It's a lot of bytes.
I could do, what about kilobytes? 1 kilobyte is equal to 1 times 10 to the 3rd bytes. So I can put any base unit in here. I chose bytes because I saw that giga, and that made me think of computers. But let's look at centimeters. 1 centimeter is equal to 1 times 10 to the negative 2 meters.
Notice how he's putting the same base unit word in on both of those lines for the row.
So using this, you can create factors to convert between metric units. Another way we could represent this is we could just put one of the base unit. So let's go to liters. 1 liter is equal to 1,000 milliliter. And this is a factor. I can convert between milliliters and liters using this factor.
So you can use either or of these tables, or you could mix the two depending on how you want to use them. But they're representing the same prefixes and the same conversions. So here's an example of converting meters into centimeters. So we start with what we know, that's not the factor. We're given 1.75 meters. I'm going to put that over 1 because I want to just make it obvious that meters is in the numerator. We always cancel units, so I don't want meters, I want centimeters. So I know I have to put meters in my denominator. So what's my factor? Do I have a factor that I can convert between meters and centimeters? Yes. 100 centimeters, just like century is 100 years, centimeter is 1 meter. So that 1 has to go in the denominator, and that means that the 100 centimeters is in the numerator. Meters cancel, we're left with centimeters. Anything in the numerator, those are multiplied. Anything in the denominator is divided. So 1.75 times 100 is 175 centimeters.
Now let's do one that's a little more challenging. This is using density. So remember we talked about combined units or derived units? That these have two, they're made up of multiple units. So here we have grams per mil. I'm going to rewrite that up here. So that this is the same as 8.94 grams over 1 milliliter. And this is a factor. I can say 8.94 grams equals 1 milliliter. That's a factor. I don't want to start this problem with this. When I see a factor, I like to write it somewhere to help me out, but don't start your problem with this. And this is confusing. Where do I start? There's multiple numbers here. Look for something that's not a factor. 454 grams is not a factor. So I'm going to start with that. And I will put it over 1 just to have a fraction. And right away, I'm just going to write grams in the denominator over here because I know I need to cancel those grams. Do I have a factor that goes from grams to a volume? I sure do. 8.94 grams is equal to 1 mil. Grams are going to cancel, and I'm going to solve this by taking 454 divided by 8.94.
Ooh, that's me. I have to calculate that. 454 divided by 8.94 is 50.8.
Since the question didn't specify the volume, the units for volume, we can go with milliliters and that'll be fine. Now there's another way you could solve this problem using the formula density equals mass over volume. You're given the density, you're given the mass, but our experience is it's kind of difficult to calculate that volume that way. And this dimensional analysis is really slick.
Yeah, so that was great. So we do have 2 other videos on our YouTube channel, scientific notation and dimensional analysis in the kitchen. So we recommend you going for more detail in both of those. Are very, very important using those videos.
In this video, we covered metric units, we talked about scientific notation, and we talked about unit conversions. And it's quite a bit of material. You're going to want to practice those unit conversions, get comfortable with dimensional analysis. It'll pay off really big in the future. Thanks. Stay tuned. Thanks for watching.